Okay, Albert Einstein was a German-born theoretical physicist, best known for his theory on relativity. Born in 1879, Albert was born with a slight defect. He was unable to talk until after the age of 3. And he said later on he conceived, he had images of pictures rather than words. Nowadays they would deem him with Asperger's, a high-performing characteristic of autism. Now everybody knows his most famous equation is E equals mc squared, or mass energy equivalence. He imagined that a glass of water would power the city of London for 2 weeks. And he imagined this before he could prove it. He came out with this in 1905. In 1921, however, he won the Nobel Peace Prize for one of his more obscure discoveries, the law of the photoelectric effect, which was a discovery which was a pivotal step towards quantum physics. Now, at the time of Einstein, Newton's equations were some 200 years old. And while his equations in physics predicted or prognosticated the orbit of all the planets in our solar system accurately, he was not able to predict Mercury. Mercury's orbit was an anomaly. Einstein understood that because Mercury is so close to the sun, that its orbit was greatly affected by the warping of space and time of the sun. So he knew that Newton had a flaw in his equations because of this. So let's take a look at that orbit. Notice that each precession around the sun, when it's at perihelion, the closest point to the sun, it's flung out a few arc seconds to the left, creating what looks like a flower or petal or a mosaic ultimately. Einstein, because of this, concluded that gravity is the effect of the warping of space and time in the presence of mass. If you said to him the force of gravity, he would say, no, no, no. It's the warping of space and time that causes gravity. Notice in this picture, mass distorts the shape of space and time around it. And it's this distortion that causes a deviation in the geometry of space that allows objects to move. Now this next one, this is another picture of Mercury. Notice its oval or elliptical orbit. Here it's at perihelion before it's flung out. Notice it looks like it's falling downhill, it's falling into the sun. And it actually is falling into the sun. The planet has enough speed, however, to get enough centrifugal force to keep from falling in. Now this is the Earth and how it's affected by space. Now what it does, its effect on space-time. Notice its deviation. This is what allows our moon to move around. Now, I want to get into his most critical formula that he came up with in 1915, and he came up with this formula after a lot of work. I mean, this is from 1905 to 1915, and this formula is the whole geometry of the universe, and it encompasses this whole idea of relativity. Let's go into it a little bit. Now, G minute, this stands for the shape of space and time, times A times pi times gravity divided by the speed of light to the 4th power times t minute. This stands for the shape of space and time. This stands for the distribution of mass and energy. This is the geometry of the world, the math. This is the physics of the world. This equal sign is most important here because it brings these two worlds together. Think of it as a two-way street. Matter tells space-time to curve. Space-time tells matter to move. Okay, so this is his defining moment. This is his signature. You never see this. You just see E equals mc squared. But this is his most important formula. Now, if you don't think this is important, think of this. If you don't think relativity is important, your GPS satellite would be off by 6 miles a day if they didn't take relativity into account. Because see, and the GPS satellite is 12,500 miles up. Because there's no gravity, time goes a lot faster than it does on Earth. If they didn't account for that, there wouldn't even be a GPS. That's just one of the results of Einstein. Now, Einstein wanted desperately that people would accept his formula, but the average person is not going to get this. Not even scientists believe it. He needed physical, hard evidence, and the only way he could get that is with showing that the stars, the light from stars coming around the sun actually bent. So he needed a solar eclipse. He needed a full eclipse. And there was a lot of failed attempts because of World War I, bad weather, whatnot. May the 29th, 1919, Arthur Eddington, the British astronomer, went down to the Isle of Principe off the coast of West Africa. And he was able to camp out there, photograph these stars before the eclipse and then during. Now, it wasn't until November of that year that Einstein's theory was proclaimed accurate. And at that time, the newspapers all of a sudden the next day made him a rock star. This is the only scientist to ever be a rock star. He was the most important man in the world at that time. The newspaper said, Einstein theory triumphs. The newspaper headlines were also like, all the heavens askew with light. Now, Einstein was good friends with Charlie Chaplin. And Charlie Chaplin said, look, people love me because they understand what I do. People love you because they don't understand what you do. Can you explain that? And Einstein just went. Now, Einstein died in 1955 at the age of 76. He died without really ever understanding quantum physics. Not many people do. He didn't understand. He thought it was spooky because how could an electron be at two different places at the same time? And the laws of physics break down on the quantum level. Nobody still understands that. He doubted that the atom could be split on this earth, but he was visited in 1939 by Leo Szilard, a Hungarian physicist, who said, look, we can take the neutrons in uranium and split the protons, cause them a reaction, a chain reaction, splitting, getting the energy out of it. So he feared that Germany was going to get the atomic bomb before America did. As a result of this, Einstein wrote a letter to President Roosevelt. The result was the Manhattan Project. Now, I can just sum up this quickly. In conclusion, I can only say that his imagination, with pure thought, solved the riddle of the universe. And he was right. It shows you the power of your thought if you can be right about something. You know, the bottom line is it's Albert's world, and we just live in it. Thank you.